All right, welcome to our second class. So this is our actual introduction to Java. That first class was kind of a warm-up. So hopefully you're watching this before um, class begins, and hopefully you're taking notes as we go through this, writing down points that are, interesting or unusual to you, or things that you want to ask questions about in class, those sorts of things. So I don't want you to just kind of, have this play and sort of take it in passively and then you're done. I want you to really try to think about the material that we're going through in the videos, and take advantage of the fact that we meet for 2 hours twice a week, and that whole time I'm there just to answer questions for you, right? To explain things in different ways, to clarify things that aren't clear here, and so on. So really take advantage of that. Try to get your first learning of the concepts in these videos, and make notes, get some pencil and paper or something, and jot down things along the way. And then after the video, try to rewrite your notes in a way that sort of captures the ideas that you think you need written down. Some things that may not be obvious when you first hear them may make more sense later on, and you may take those out of your notes. Other things may become apparent to you, and you'll add those to your notes, and so on. And then after watching the video before the class, go ahead and take the online quiz as kind of just sort of a quick spot check on some of the concepts from the video. So Java is object oriented, and two words to sort of get squared away on up front. There's the notion of a class and an object, and these are related but not the same thing. Objects are like variables, and classes are kind of like types of variables. So if we say something in C like, integer x, or struct node data, right? This thing or this thing, that's a type of a variable. That roughly corresponds to what a class is in Java. And these things, data and x, those roughly correspond to what we'll call an object in Java. The way we actually think about it, though, is an object is a particular version of some sort of class. So sometimes it's helpful if you think of building a house from a blueprint. The class is kind of like the blueprint, right? We could make a lot of different classes. We could have a blueprint for a one-story house. We could have a blueprint for an office building. We could have a blueprint for an apartment complex, right? And with a particular blueprint, we could make multiple objects. If we have the blueprint for a one-story house, we could make 5 or 10 houses from that blueprint, right? So a class will describe a particular set of things, data and code, and then we can construct one or more versions of that to get one or more objects. So we're going to do some very specific examples of this in a little bit, and that should help clarify these kind of abstract notions. But let's start off with just kind of easing into a bit of Java code. So again, I'm going to work on our Linux server. I've made my CSE 223 area, and I'm going to make a class 2 area, and I'm going to do all my work from here, just to kind of keep things straight. And I'm not going to do all the problems from the problem set, but just as an example, I'm going to organize my work like this so that I can keep my work around. So first thing we want to do is just kind of look at some of the things we can do in Java that's similar to the things we can do in C. So let me make a program1.java. And we're always going to begin, a file called program1.java is going to have a class called program1. And we're going to make a main program. We've done this the last time also. And this is kind of our template for, a pretty generic class that's just going to have a main program. And what we did the last time was kind of a hello world, where we just put a print statement in here, like that. And so if I compile this, I get a .class file. That's the compiled bytecode, and then I can run that by saying Java and the name of the class file, and it executes the code. So we can do things that we're already familiar with from C. For example, I can say, you know, integer x comma y comma z, x equals 10, y equals 20, z equals x times y. So this should be 200. So we can use variables like this. Now, outputting variables in Java, we don't have to deal with printf and %d and all of that funny business. So we can do some things like this, for example. I can say print, let's say x equals we can do these concatenations. This plus sign basically says, okay, I want to print out x followed by an equals sign, and then I want to append or concatenate to that string just the variable x. And then I want to print out the string y equals, and I want to append to that string the value y, and then I want to print out and z equals, and I want to print out the value of z. So let me make a new window here for compiling, and it's a Java file. Oh, I don't have myself set up to go into, oh, wrong machine. Okay, here we go. So I'll compile that. It's still program 1, and then I can go ahead and run that. And oh, so I haven't written my changes yet, so let me write that out. Let me compile my program, let me execute my program, and so it says x equals 10, y equals 20, z equals 200. Right? So so we can use, you know, integers the way that we do in C. We can do arithmetic operations, we can do assignment statements, and we can do output more easily than with a print statement, you know, printf with a %d and so on. We can just sort of use this concatenation operator. And we can get somewhat fancy with this. X plus y equals, and I'm going to put parentheses here to say, hey, I want to add x and y together, and then I want to take that number and concatenate it to this string. So if I do that, and I run my program, it says x plus y equals 30. So we can do, you know, things that we're used to doing in programming. We can also do things like for loops. So I could say for integer I equals 0, I less than 10, I plus plus. And let's just print out I equals I. Right, so basic for loop, I'll go from 0 to 9. We'll print out the value of I after each increment. So compile that and run it, and you know, we've got a loop. So I mean, this looks exactly like C. It's the same syntax. We can declare our variable inside the for loop, or we could declare it outside. All of that works the same. So as we're working in Java, it will feel sometimes like we're doing C, and that's okay. We can leverage our C understanding to help us with Java. But it's important to remember that we're not doing C, we're doing something object-oriented. So we're going to be working with these classes and objects. And even though, you know, we can write C code and put it inside a Java program, we want to do more than that. We want to move into actually writing Java code in Java. And one thing we can do in Java that we can't do in C is we can declare a variable to be a string. So I could say string cool variable, and I can say this is a real string. And then if I want to print that, I can say my real string looks like, and I can concatenate coolvar to it. And if I do that, compile it, and run it, and you can see my real string looks like this is a real string. So we have genuine strings in Java. They're no longer arrays of characters. They're no longer pointers to memory where we have the first character. They're no longer null terminated. They're a legitimate built-in type of variable or object, and we declare them with the word string. String is also an example of a class, right? It's a type of variable, and coolvar is an instance of that variable, what we call an object. So let me just put a comment down here. String is a class. Coolvar is an object, which is an instance of the string class. We'll encounter this again and again and again, and it will sink in over time. But for now, let's just think string is a class, right? It's a blueprint for how to build something, and coolvar is a thing that we've built using that blueprint. It's an instance of that particular class, which means we call it an object. All right, so we have variables, assignment statements, and so on and so forth. We have for loops, so we can do looping and good things like that. So let's take a look at this this main program, this business of string bracket bracket args, and see what's going on with that. So in C, you know, when we write a main program, we have argc, argv. Argc is how many arguments. Argv is an array of strings, but it's not really an array of strings. It's an array of pointers to memory locations where we have null terminated characters. It gets kind of, you know, confusing and wonky. In Java, this is just an array, right? So string is a type of object. It's a class. The bracket bracket says we have an array of these things, and I'm calling that array args. And args is simply, you know, an array of strings. So let me get rid of a lot of this code. So since args is an array, the way that we can find the length of an array in Java is just to say .length. So remember in C, one of the big gotchas is that arrays don't actually have a length. We keep track of how long they are, or we put a special character at the end to say this is the end of the array. But a plain old array in C, there's no length. There's no way to tell if that array is 1 character, 10 characters, 1,000,000 characters, or integers, or anything else, unless we use some kind of convention. In Java, arrays have a length, and we can find the length by looking at args.length. So if we say args.length equals, and we just append the length of that to our string, we can run this and see what the length of this array is. So let me compile it. Oh, I put parentheses. I don't need parentheses here, right? So we'll do parentheses later. So let me compile this, and let me run it, and it says args.length equals 0. Okay, what's the big deal there? If I run it, and after the name of the program, I type some other things separated by spaces like these are command line arguments, well, now args.length is equal to 5. And guess what? It took these 5 words, these are command line arguments, and it put them into an array. And it said that array has 5 things in it. So when I asked for the length of the array, it said 5. And if I want to see what the elements of that array are, I can just access them by using brackets. So let's print the contents of the args array. So let's use our usual looping structure, I equals 0, I less than args.length, I plus plus. And I'm going to do some slightly fancy concatenation. I'm going to print out the string args bracket, followed by the value of I, followed by a close bracket, an equals sign, and then the value of args bracket I. We did this in 224 when we explored argc, argv, right? We did similar loops. We're doing the same thing here. This is just, exploring what this array looks like. Since we're required to put this as the argument to our main program, let's see what its length is, and then let's see what each of the elements look like. So this is test code. Compile that. And then run it. And not surprisingly, arg0 is the word these, args1 is r, args2 is command, and so on. So this is how we get to command line arguments. All we have to do is pull off the arguments from this args array, args bracket 1, args bracket 0, and so on. And this is Linux, so if I do something like this, bash will take all of this, since it's in quotation marks, and pass that as the first argument to my Java program. So now args.length is 1, and the first argument, args bracket 0, is this entire string that happens to contain spaces. So rehashing some of the things we observed and used in CSE 224, but in a more modern language. All right, so that's all we need to know about command line arguments, right? We always put in this string bracket bracket args for our main program, and then we can just treat this as an array, index the elements with args bracket some index, and we can find the length of the array with args.length. Now, this dot notion is perhaps familiar from making structures in C. So in C, if I do something like struct data integer x, integer y, and then I say struct data vector. Vector is a composite type of variable. It has two fields, x and y. Remember, if I want to get to the x field, what do I say? I say vector dot x. And that means this thing in this particular instance of a struct data. So again, this is like a class, this is like an object, and if we type the name of an object, period, the name of a field, it gets us that field from the structure. So same thing is happening here. An array is like this composite structure. It has, among other things, a field called length. And the virtual machine sets that up to tell us how many things are in the array. So we can say args.length, and we're doing the same thing as if we say, vector.x in C. So arrays work a lot more nicely than they do in C. All right. So that's it for kind of the high-level intro. Let's talk about making classes. And so, a lot of what we're going to do in Java is we're going to create our own classes. And there's built-in classes like string. There's classes like linked list, hash maps, things like that. But a lot of times you're going to want to make our own classes. And that's really where an object-oriented language sort of breaks off from a language like C, is that we can extend the language in some sense by defining our own classes to do whatever we want to do. So I'm going to pick a pretty standard kind of simple example of a class. We're going to make a class of rectangles. And what is a rectangle? Well, it's a four-sided thing, parallel sides. It's got a length and it's got a height. And doesn't need a whole lot more than that, right? So, and these might be, you know, real numbers, so we can make them doubles, and double is a type in Java. Um, but the idea is, you know, I want to be able to create a rectangle and not have to talk about its length and its height. I want a single variable, an object, that contains both the length and the height of the rectangle. So, you know, one more time in C, we could do this by saying, you know, struct rectangle. And then we could say there's a double called length, and there's a double called height. And then we could declare a variable of type struct rect, and we could say rect.length, rect.height. So that's kind of the starting point for what we're going to do in Java, but we're going to get away from that pretty quickly. So I'm going to make a class called a rectangle, and anytime I want to make a class called something, it has to go in a file called something.java. So here's my rectangle class. So this is a simple class for rectangles. So I begin with the keyword class followed by the name of the class, which is rect, and then a curly bracket. And, you know, at this point, I've got a rectangle class, right? It doesn't do anything. There's no code in here, but it is a rectangle class. And I could take my, my program, and I could do something like this. I could say R1 is a rectangle. And I could even print out what the value of R1 is. Right, by appending it to a string like R1 equals. And this will work, right? This is perfectly valid code. So if I look in my directory, I've got, you know, program 1 that I've been developing, and there's the compiled version. I've got a rectangle.java that I just wrote. If I say java c program1.java, it will compile that, and it's going to give me a warning that R1 has not been initialized. But if I do an ls, oh, I don't have a rect1 yet. It's giving me a warning that R1 has not been initialized. This is another thing Java does that's different from C. In C, if we say integer I and we don't give I a value, the code just runs. And maybe you get a 0, maybe you get some random value, maybe it's different from machine to machine. But Java does a lot of work to try to save you from these kinds of issues. And really, I shouldn't be printing the value of R1 if I haven't given it a value. So how do we give a rectangle a value? Well, we can say something like R1 equals new rect. And this takes the place of our malloc statement in C. So it's kind of like malloc, but not really. But one thing it does is it allocates resources like memory to be able to store R1. But it can do a lot more than that. So like this, I've declared R1 to be a rectangle. I've initialized R1 to be a new rectangle, right? And what's the difference here? Rectangle is a class. R1 is an object. I've declared it to be an object, but I have not constructed that object yet. Right? It's like, you know, this is the blueprint for the house, and I've said, okay, I'm going to build a house in this location, but I haven't built it yet. This is where it actually gets built when you use this new keyword. So now if I compile this, right, it will compile, and if I do an ls, I'll see my rectangle.class. That's the compiled version of rectangle.java. And now if I run my program 1, it will do something, but not something very exciting. It'll print out R1 equals and then something that looks kind of suspicious. But it does run. It did construct a rectangle here, and then it printed out something. All right, So let's make this rectangle class actually do something like a rectangle. So in C, we said that, we would make a pair of fields like a double length and a double height to store the dimensions of the rectangle. Well, let's do that in our Java class. So we'll say double length, double height. And now let's do something different with our main program. Let's say r1.length equals 10 and r1.height equals 12. And then let's print out the dimensions of the rectangle. Like that. So r1.height equals 10, r1.length equals 10, r1.height equals 12, and then I can use those and retrieve them by saying r1.height, r1.length, and I should see that its height is 12 and its length is 10. I need double quotes in the beginning here, so I can compile this. And then if I run it, there's my rectangle, height is 12, length is 10. So far, we're using this the same way we would use a structure in C. We're storing multiple fields inside this class, right? And then when we make an object that's an instance of that class, we can use this dot field name to set or read values from that field. So far, not very different from just a structure. The difference is that in Java and in other object-oriented languages, this class can contain not just data like height and length, but it can also contain code. So let's see what that looks like. I'm going to make a method, a function. So functions in Java are called method, called area. Which returns length times height. So here is a function, which is called a method. Calculating the area of a rectangle. So if I try to run this code area, what should it do? It should take the length and the height, multiply them, and then return that. So to use this, I can do something like this. The area of R1 is, and I can say R1.area, and since I'm running a function, I put parentheses after the name to say, hey, this is a function as opposed to just a field like length or height. And when I try to do this R1.area to find this value to concatenate it to the string, it's going to actually call this code. And this code is going to say, okay, what's the length of R1? What's the height of R1? Let's multiply those and return them. So if I compile that, and then I run it, it says the area of R1 is 120. So this is the leap, right? This is where we start thinking about objects as being fundamentally different from structures in C. So let's expand this. Let's make R2 is a new rectangle. And let's make R2 a 5 by 7. And let's print out R2's area. So the area of R1 is R1.area. The area of R2 is R2.area. So let's run that and let's come back and talk about it. So compile that. Oh, I forgot to say rectangle R2. And, like other languages, I could say rectangle R2 on a separate line, or I can use a comma here and declare two rectangles. So compile that and run it. Area of R1 is 35. Area of R2 is 0. I messed up here. So run that. The area of R1 is 120. The area of R2 is 35. So these are different objects. They're both objects of type rectangle. They're instances of the same class, the rectangle class. But R1 has its own length and height. R2 has its own different length and height. And in some sense, each of these has its own function or method called area. And when I say R2.area, I'm running that area method inside R2, which means that when that area method looks for length and height, what are the length and height it's going to find? It's the length and height of R2. When I say R1.area, it's the same function. It's still saying return length times height, but in this case, it's the length and height of this rectangle R1. And if I do something like, let's change R2's height, R2 height equals 100, I can say the new area of R2 is, and see what R2 area returns. Right, and so R2 was 35, now its area is 500. So R2.area is not like just reading a field from a variable, right? It's running code kind of inside that variable itself. And so if you think back to 222, we talked about abstract data types. And we used the word encapsulation, meaning we want to take data, and we want to take code that manipulates that data, and sort of think of those two things together. And we wanted to kind of firewall them from the user. So the user just thinks about, I've got a stack, I've got a linked list, I've got a binary search tree, and doesn't worry about, I've got a stack pointer, I've got a sentinel node, I've got a left and right child, right? The user of these data structures just thinks of them as sort of a box that does things for you, and they don't worry about what's inside that box. Well, that's what we're trying to do here. We want to find the area of a rectangle. We just say R2.area. We don't need to know that it's got something called a length and a height. We just call R2.area. As opposed to, taking R2.height and R2.length and multiplying them or passing them to an area function or something like that. The code is bundled in with the data, right? So it can do something like this. And we just now think of R2 as a rectangle. R1's a rectangle, R2 is a rectangle. All right, so let's take this a little further. Let's think about this business here where we're setting the length and the height of the rectangle. And that's not a horrible thing to have to do, but anytime we create a rectangle, we've got to say rectangle.length equals this, rectangle.height equals that. If we've got to do that over and over and over again, let's find a more convenient way to do it. So, we constructed a rectangle by saying new rect, but it would be really nice if when we constructed this rectangle, we could have instead said new rectangle 10, 12, and not had to do this. And for R2, we could have said new rectangle 5, 7, and not had to do that. And we have the ability to do this. So this thing, when we say new rectangle 10, 12, that's called a constructor. It's a function that creates a rectangle. And if we don't tell the constructor to do anything, it just does, the allocation of memory, the bare minimum that's needed to make this work. But we can actually specify a constructor ourselves. So let's define a constructor for a rectangle. So I'm going to say public to say other classes can access this. I'm not going to put in a return type, and this is what makes this a constructor instead of a function or a method. There's no return type specified, but the name of the function is just rectangle, and then I can put whatever arguments I want on it. So I'm going to say double, and I'm going to say, well, I don't know if I want to do length, height, height, length. I'll do double H and double L. And in the constructor, I'm just going to say height equals H, length equals L, and that's going to be my whole constructor. All right, so how do these pieces fit together? Up here, I'm going to say R1 equals new rect 10, 12. When it sees that declaration, it's going to come into the rectangle class. It's going to look for something called rect that's public that takes 2 arguments. And when it finds it, it's going to set H equal to the first argument, L equal to the second. So this statement right here, R1 equals new rect 10, 12, is going to say, hey, H equals 10, L equals 12. And when this code runs, it's going to set height equal to 10, length equal to 12. So that will do that initialization that we were doing kind of by hand in here when we said R1.height, R1.length, and so on. So if I compile that and run it, it does exactly the same thing. R1 is 10 by 12, area of R1 is 120, area of R2 was 35, and then we changed from 5 to 100, and so now the area is 700. So this is called a constructor, and in this case it takes these arguments and it creates the initial dimensions. And if we're making something like a linked list, we know that when we construct a new linked list, we need to have a sentinel node with certain properties. Well, we could take the code for doing that initialization and put it in our list constructor. If we're creating a class for a stack, we know that we need to initialize a stack pointer to 0, or we need to make a linked list with a sentinel node pointing to null. We could take the code for doing those things and put them in here. And remember in 222, when we wanted to implement a stack using a linked list, we needed to have a sentinel node. And I said, okay, in this case, you can make it global. Well, we could put the sentinel node up here as part of our stack class. And then I could make, multiple stacks, and each stack would have its own sentinel node. And each time we constructed, the constructor would set up that sentinel node to point to null, and so on and so forth. And then in here I could also put methods for pushing and popping and seeing if the stack's empty and so on. And then in my main program, or some calling program, I could have a class called myStack. Not myStack, myStack. And I could just call it, S. I could construct it as a new myStack. And that would initialize it, and then I could say s.push 10, s.push 20, s.pop, and so on. And I could make a separate stack called t, and I could say t.push, t.push, and it would be a completely separate data structure that I could be pushing and popping from, independent of this first stack s. All right, so those are things to keep in mind. This is the constructor notion. So the last thing I want to talk about for today is the idea of arrays. And arrays are a little different in Java from what we do in C. So let me make a program too. Copy some of my code. So if I want an integer array, I can do the following. All right, so let's make a program too. Here's kind of our boilerplate. Let's make an array of integers. So I can say integer, let's say data bracket bracket equals new integer bracket 10. So that's an array of 10 integers. And I can initialize some values in here. So for integer I equals 0, I less than 10, I plus plus. And let's say data bracket I equals I times I. So let's just store squares of integers. For no particular reason. And now print contents of the array. So for I equals 0, I less than 10, I plus plus. And let's print out data bracket I equals plus data bracket I. All right, so I'm declaring a variable called data. The bracket says it's an array, and we need to say, you know, equals new int bracket 10. And then we can use data bracket 0, bracket 1, bracket 2, all the way up to bracket 9. And in this case, I'm just initializing some values, and then I'm going to make a loop and print out those values just to see if our array is actually storing things. So let's compile that. And let's go ahead and run it. And sure enough, it stored, you know, the squares of the index. Now, if I tried to do this up to, say, you know, element 10, and then I run it, I get a nice clean exception. Instead of saying segfault or, you know, just corrupting memory, it tells me array index out of bounds exception. Index 10 is out of bounds for a length 10, and it's at line 13 of program2.java. So I can go to line 13, right, and it's this line that's highlighted right here, and you know, it's telling me that my index of 10 was too big, because if I set it up to be 10 ints, the indexes only go from 0 to 9. But you know, I could also avoid this by, instead of saying 11, I could say data.length and actually see how big the array is. And you know, I know it's 10 elements because that's what I set it up to be. But if I didn't know that, or if I was doing this in a function and I had just passed this array called data to a function, I could use data.length to see how big it is. So we don't need to pass the length ourselves. It's part of the array. So again, arrays are an actual thing in Java. All right, so this new keyword here is kind of interesting. In C, when we make an integer array, we just say integer data bracket 10, and we're done. But we're not really done, right? We still need to initialize it, but we don't need to allocate memory for it in C. When we write a C program and we say integer data bracket 10, the compiler and the linker work together and arrange for there to be a chunk of memory somewhere that array points to, so that there's place to store our 10 integers, for example. But in Java, we're actually using the new keyword, right, which is kind of like constructing an array of integers. And then we're saying, okay, so our data array basically points to, you know, these 10 integers in memory. And it seems a little weird in this context, but in a different context, this will make more sense. So for example, suppose I want an array of rectangles. I could say integer data bracket equals new rectangle bracket 10. So now I'm making an array of 10 rectangles. And if I don't do anything else, let's just take all of this out of here. My bad here. This is a rectangle array. So rectangle array data equals new rectangle bracket 10. So we can compile that. It compiles fine. It doesn't do anything when we run because, you know, there's nothing in here that we're asking it to do. But this is basically allocating space and memory for 10 rectangles. So it's doing part of the construction of the array. But before we can actually use that array, we need to do one other thing. So for example, if I try to say data bracket 0 dot length equals 10, right? Because data is an array of rectangles, so data bracket 0 should be a rectangle, and it should have a length. But if I try to do that, right, and then I try to execute it, I get an error. This is the famous null pointer exception. This is a seg fault, right? It's the same situation that causes a seg fault in C. And the problem is we've said data is an array of rectangles, but we haven't constructed any rectangles. All we've done is set up space for 10 rectangles, but we don't actually have any rectangles yet. So if I first say something like data bracket 0 equals new rectangle, and you know, I'll give it some dimensions like 5 by 7, then I can say data bracket 0 dot length equals 10, and that'll work just great. Except I gotta use my uppercase correctly. Right, and I can run that, and again, it still doesn't do anything noticeable, but it's constructing rectangles. So suppose I want to make an array of actual rectangles, I could do something like this. So let's just go from 0 through 10, and let's say data bracket I equals new rectangle. Let's just do I plus 3 comma I plus 5. So we'll just give some sort of random dimensions to our rectangle. And that should compile fine. So let's print out our rectangles. Let's print out the areas of our rectangles. So area of rectangle number, and I'll print an I, and I'll just say data bracket I dot area. So we construct 10 rectangles up here in an array, and then we loop through and we print out the area of each of those rectangles, like that. And so if we do that, we run our program, there we go. The first rectangle was 3 by 5, the second was 4 by 6, the third was 5 by 7, and so on. And we can see the areas of the rectangles. So we actually have 10 rectangles, each with different dimensions, and they're all stored inside this one object called data, which is really an array of rectangles. All right, so this is a first introduction to most of these concepts. The array stuff is a little bit quirky, but the more we work with it, the more it will make sense. So this is the first introduction to it. But the main takeaways are the ideas of defining a class, like a rectangle, being able to define methods, right, functions inside there, and then access those by using the name of an object, period, and the name of the method, and also the notion of constructors, where we can specify ways to construct a rectangle. And we will build on that in another lecture when we talk about signatures of methods and constructors, but this is plenty to work with for today. So today's problem set, 19 questions, where you're going to basically go through a lot of the steps that we've gone through here, but you're going to do it on your own and explore some of these concepts more deeply. All right, so that's the class 2 video. I'll see you in class.